In order for a computer to communicate with other devices on a network, it needs to have an IP address. Now, in years gone by, administrators would have to assign each device in the network its own IP address manually. Now, if you're an administrator, could you imagine having to go around to every single client computer in your company and manually configure an IP address on each of them? Of course not. Does that sound like fun? Then imagine one of those computers has to change its IP address. Now you'd have to go and revisit each of those machines again and update all of them. It's a ridiculous waste of time and resources, and it's exactly the reason that DHCP was invented. So nowadays it's just assumed that you'll have a DHCP server to take care of all of those IP address assignments for you. So in this video we're going to build a DHCP server that'll do just that. Now we'll get to building our DHCP server in just a moment, but first let's briefly discuss how a DHCP server does its thing. So when we have a device that's been configured to use DHCP, it needs an IP address. Now the process goes something like this. Now let's just assume that it's your desktop computer here, and in the morning you arrive at work, and obviously the first thing you do is you switch on your computer. Well, the first thing you do is normally get a coffee, but after that you switch on your computer. Now as this machine here boots up, it needs to get out onto the network, so you can do all the cool time-wasting things like visit YouTube and Twitter and Facebook and all of those sort of things. So when this machine does boot up, it needs an IP address. Now right now though, not only does it not have an IP address, it also doesn't know where a DHCP server is located. So to find one, it broadcasts for one. So it broadcasts a packet which is called a DHCP discover packet, which essentially just asks the question, who out there on the network can give me some information about DHCP? So it's kind of like standing there in a crowd and shouting out for somebody who can help you. Now the DHCP servers, they're out here, they're sitting out here on the network somewhere. Some of course are different shapes to the others. And these guys, they're configured to listen and respond to these sort of requests. And these guys can all send back to this machine what's known as a DHCP offer, which is really just an answer to the machine's original question. The clients ask, hey, who out there on the network can give me an IP address? The DHCP service responds with, me, I can give you that information, here's what you're after. So for our client though, when finally it accepts an offer from one of these three servers, let's just say it picks the offer from this server, it's going to broadcast back to everyone and tell them that it's chosen server A in this case. So our client tells server A, here's my MAC address, can you please give me an IP address? Now at this point, all these other DHCP servers, B and C, they know that they haven't been chosen, so they're just going to abandon that request, and for them, it's just going to be business as usual. Now, for our winning DHCP server here, server A, it's going to send back the client a DHCP ACK, which is short for acknowledgement. Now in this packet is the IP address that the client asked for, along with some other information such as where this client machine can find a DNS server and things like what the default gateway is. Now the final step is that this DHCP server is going to take the IP address that it just gave out to that client machine, and it's going to remove it from its list of available IP addresses so it doesn't accidentally hand it out by mistake to another machine. Alright, well, so we've just talked about a bird's eye view, a simplified view if you like, of how DHCP works. So let's get stuck into the practical aspects now. Let's go and build a DHCP server. So on our Windows 2008 server here, the first thing we'll need to do is open up our server management console here. Up the top we'll click Roles, and then we'll choose Add Roles. Now this will start up the Add Roles wizard. We've seen this all before many times. We'll choose a DHCP server, and we'll click Next. Now I'm going to ignore this introduction to DHCP. You could read that in your own time if you like. We'll click Next. And firstly, we'll need to choose which network interfaces we want to use with DHCP, or as it's called here, network bindings. Now in my case, I only have one single network card anyway, so I've really only got one choice, and obviously we'll be using this one. But if your server has multiple network cards, which is a very real possibility, therefore it could be connected to multiple networks or different subnets, it'll be able to service DHCP requests for each subnet that it's connected to. So here, you're simply just selecting which network card is allowed to service the client requests. Well, I've only got one, so I'll leave it as it is. We'll click Next. Now here we can configure IPv4 specific DNS settings. Now when our DHCP server hands out an IP address to a client, it can also hand out the name of the domain. In my case here, we've got jawkus.com. And it can also hand out the IP address of 1 or 2 DNS servers. Now, although you'll probably find that these fields are already populated with the correct information, I would recommend that you do just review that information here. Make sure the name of your domain and any IP addresses of any DNS servers are correct, which they are in my case, so we'll leave them and we'll click Next. Okay, are we going to use Wins in our network? Ideally not, but if you have old applications that need it, you can select this bottom radio button here, then enter in the IP addresses of your Wins servers. Now, I don't want, and neither do I need Wins, so I'm going to leave the default, and we'll say Wins isn't required, and we'll click Next. Okay, well here's probably one of the most important windows that you'll need to configure, as here is where we'll define a DHCP scope. Now, a scope is simply a range of IP addresses. That's it. It's just a range of IP addresses that you'll hand out to clients that ask for an IP address. Now, whilst you can continue along with this wizard, just click Next here without even creating a scope, you won't be able to give out any IP addresses until you create the scope. So it's important that we do create one. So let's do that now. So we'll click the Add button. And the first step is to give this scope a name. Now, it really doesn't matter what we call the scope itself, but preferably it'll be something descriptive though. So let's call ours New York. Then we'll need to specify a starting address and an ending address as well. Now, the most important thing you need to consider when choosing this range of IP addresses is really how many clients do you need to support with this IP address range. Now, if you've got 100 PCs in your company, you might think 100's okay. But what about guests in your network? What about network devices? What about phones and wireless devices and laptops and so forth? Now, you very well could find that your estimate of 100 is more like 200 or 300. Now, you want to plan for growth and expansion as well. So in here, I'm going to set a starting address of, say, 10.32.1.100. I'll allocate through to 10.32.1.200. There's 100 IP addresses there, and a subnet mask 255.224.0.0. Our final step will be to give it a default gateway, 10.32.1.1, and I'm going to leave the subnet type here as wired, although we could create this as a wireless scope if we like. And finally, we're going to activate this scope so it's live once we've finished this wizard. All right, we'll click OK, and then we'll click Next. All right, well here we're starting to move into the IPv6 settings. So do we want to enable DHCP v6 stateless mode or not? So this DHCP v6 stateless mode allows clients to automatically configure their own IPv6 addresses. So what it's asking here is, do you want to use the DHCP server to hand out IP addresses to IPv6 clients? Or do you want to disable this and let those clients figure it all out for themselves? So I'm going to leave the default here to enable that mode. We'll click Next. Again, for IPv6, we can configure our DNS server settings. We've seen this screen before for IPv4, so this is exactly the same. I'm going to accept these defaults. We'll click Next. All right, we're almost done here. We now need to specify an account that has permissions to authorize this DHCP server in Active Directory. You see, around the time that Windows 2000 came about, there was a problem with DHCP. Now, it was common for people like you and me to build a lab box just to play with Windows Server to learn more about it. Now, we didn't intentionally build a DHCP server to muck up any production machines, but by installing DHCP, even without trying, it'd start responding to requests for IP addresses, and it would get in the way of the real DHCP server. So to solve this problem, Microsoft made it so that you would have to first authorize your DHCP server in Active Directory first, before it would start handing out IP addresses. So I'm just going to use our current credentials of the person that I'm logged on with now, but you could specify a different account if you like, or simply skip this authorization step for now and do it later. Just be aware that you will need to do it, or this DHCP server won't start handing out IP addresses until you do. So I'll go with the default to use the account that I'm logged on with now. We'll click Next. We'll get our summary, and if everything looks good, we'll just click Install. Now, as you might expect, this can take a few minutes to complete, so I'm going to pause the video here, and we're going to come back in a moment. Okay, it's done. Our installation was successful, so let's click Close. And we can now go and launch our DHCP console by clicking Start, going to Administrative Tools, and up the top here you'll see DHCP, so we'll give that a click. Alright, now let's just expand this console, and if we come over to the left here and expand our server, which is dco1.jawkis.com, and we'll expand IPv4, you should see here that we've got this little green upward pointing arrow over the icon, which indicates that this machine is authorized and it's up and running. Now, if you didn't choose to authorize your DHCP server at the end of the DHCP installation wizard, then you will need to do that before you can start using it to hand out IP addresses. So if we right click on our server name here, in my case DCO1, we've got an option here to unauthorize this server. Now if your server isn't authorized like mine is, you'd expect to see the word authorized here instead. So give that a click, and as long as you've got permissions to do it, you'll be ready to go. Now while we're here, the other option, which is worthy of note, is the top one here, add or remove bindings. Now remember, when we were in the installation wizard, we were asked to choose which network adapters we were going to be handing out IP addresses to clients on the subnets that they were connected to. Well, right here, you can change that if you need. So if I was to add another network card to this server and configure it so it was on a different subnet, for example, over here you can see my scope is 10.32 scope here, the 10.32 network. So let's say I've just plonked another network card inside this server and I've given it an IP address of 10.64.0.2. Well, that card would be on the 10.64 network. So I could come here into the binding section and check the box next to each of the network cards, or uncheck them if I decided that I didn't want this server servicing a request on any given subnet. Now the same goes for IPv6, by the way. These two tabs here, they're pretty much identical. Now in order to make changes to DHCP, by the way, we've got two new groups that have automatically been created in Active Directory. So if you don't have administrative privileges on this server, you will need to be granted them. So before we get too far into this video, let's see how you can assign permissions to other users so they can come into this console and potentially make changes. So to do that, we'll click Start, we'll go to Administrative Tools, we'll launch Active Directory Users and Computers. Now we'll go to our domain, we'll expand that and go to our users container here. Let's just move this over a little bit. Here you'll notice that we've got two new groups. We've got the DHCP Administrators group and the DHCP Users group. So if you want specific users to be able to come in here and manage and configure DHCP, you'll need to add their account to this DHCP Administrators group. They'll be able to come into this server and make changes to it. But on the other hand, if you'd only like specific users to be able to come in to our DHCP console, but in a read-only style mode where they can see everything, but they can't change anything, such as a manager, adding their account here to this DHCP Users group will grant them those view-only permissions to the console. All right, well, let's close up Active Directory Users and Computers. We don't really need it anymore. And let's go back to our DHCP console. So over here on the left-hand side, under our IPv4 section, we can see our scope that we created in the DHCP Role Installation Wizard. It's from this scope that we'll be handing out IP addresses to clients that request one. So if we expand this and we select the first option here, Address Pool, this is going to show us all of the ranges of IP addresses in our scope, which currently is from 10.32.1.100 all the way to 200. So any IP address in that range can be handed out to a client that requests an IP address. And this address pool screen is also going to show any exclusions that we might have set. Now an exclusion is an IP address that we won't hand out. So let's create one so we can see what we're talking about. So let's say out of this complete range here of IP addresses that there's, say, 10 IP addresses that we don't ever want to hand out. So to create an exclusion, we'll right-click, we'll choose a new exclusion range. And we just simply need to type in the IP addresses we want to exclude. So let's say 10.32.1.150 to 10.32.1.160. And we'll click Add. And now we'll click Close. And here you can see our exclusion has been created. And you'll also note that this range of IP addresses are excluded from being handed out. And they're easily identified by this icon, which has got a red X over it, indicating that these IP addresses here will never be handed out to clients. Now, if you do no longer require this exclusion, we'll simply right-click on it, and we can choose Delete, and simply click Yes. All right, well, we'll leave that there. The next section we have here is the Address Leases section. Now, this shows the IP addresses that this server has assigned to clients. Now, this is currently blank because I've only just built this DHCP server, and I haven't yet had any clients request an IP address. So let's go and fix it. Now, I've just switched over to a Windows Vista machine that I've got on my network here, but currently it's using a static IP addresses, one that I've just assigned to it. So now we've got a DHCP server, let's go and make some use of it. So on this machine, we'll click Start. We'll go to Network. I'm going to fire up the Network and Sharing Center. Over on the left, I'm going to choose Manage Network Connections. Now there's my network card right here, so let's right-click on that. We're going to choose Properties. We'll select IPv4 and we'll click Properties again. And you'll note here that everything's been set manually, so let's choose to obtain our IP address automatically and our DNS server address automatically. We'll click OK and we'll click Close. So now let's go and open up a command prompt here and we'll type in ipconfig/all. And if we scroll up a little bit here, you can see that we've now been assigned an IP address of 10.32.1.100, which of course is the first IP address in our range, in our scope there. We've also been assigned a default gateway here, a DHCP server, we know that, and our DNS server information as well. So everything's looking good. This client was able to get an IP address without any fuss, and from this client's perspective, we really didn't have to do anything. So I've just switched back to our DHCP server, and we're still here at our Address Leases section. So if we refresh this, now up here you can see we've got one IP address listed here in our lease section. It's this address here, 10.32.1.100, and it's been assigned to the machine called client01.jawkis.com, which is our Vista machine, of course. Now it's set to expire at this date and time, and we can see some other information about it, such as its unique ID and whether or not network access protection is being applied. Now, the next section over here on the left is where we can set up reservations. Now, reservations allows us, as the name suggests, to reserve IP addresses from our scope. So let's talk about reservations. Let's suppose that Jordan, one of our field engineers, he calls me up and he tells me that he needs to put a new server on our network, and this server needs to have the same IP address issued to it at all times. Now, I could tell Jordan to use a static IP address, or I could use a reservation to ensure that my DHCP server doesn't go and hand out his IP address to somebody else. So let's create a new reservation. So we'll right-click on reservations. In fact, we'll select reservations first, then right-click on it. We'll choose new reservation. We'll need to enter in a reservation name. So let's just say this was Jordan's server. We'll enter in the IP address we want to reserve. Let's say 10.32.1.120. Now we'll need to also enter in the MAC address of the computer's network card and an optional description of the reservation, just to make future identification a bit easier. So to get this MAC address here of the computer though, we'll just simply open up a command prompt and we'll type in ipconfig/all. We'll hit enter. And if we go and scroll up a little bit here, you can see this line, the physical address. That's this computer's MAC address. So that's the MAC address for this machine, but what if it's not this machine that I need the MAC address for? What if it's a remote machine that I can't log on to directly? Well, in that case, there's two commands that we could use to get that MAC address. The first thing, though, we'll need to do is to ping the target host. So from our command prompt here, let's just go and ping that Windows Vista machine that we were on a moment ago. So let's type in ping client 01. And all right, there we can see that our ping was successful. So now we're going to type in ARP-G. And in this list, we'll need to locate the IP address that we just got back, which of course was 10.32.1.100. So in this list, there it is, 10.32.1.100. And right here next to this, we can see the MAC address for that Vista machine. So what I'll do here is I'm going to right click and choose Mark. And now we're going to highlight that MAC address and we'll hit Enter, which will copy that text to our clipboard. Now we'll minimize this. We'll come back here to our DHCP console, right click and choose Paste. Now as it stands though, our DHCP console won't like this address with all the hyphens, so we'll need to first go ahead and delete all of those. Okay, well that's done. So finally at the bottom here, we can elect to only provide this IP address to a DHCP or a boot P client, or both. So let's just leave the default. We'll click Add, and then we'll click Close. Alright, well I've just switched back to this Windows Vista machine here, so let's, from our command prompt, type in ipconfig/release, and that'll release our IP address, so we will no longer have that one assigned to us, and then we'll type in ipconfig/renew, and that'll tell this client to go out, locate our DHCP server, and fetch a new IP address. Alright, well the command's completed successfully, so now you can see from the output we've been assigned a totally different address, 10.32.1.120, which of course is exactly what we just specified in the reservation that we created. So back in our DHCP server, if we go and click on Address Leases, and let's refresh this, you'll note now that our Vista machine here has now the IP address of 10.32.1.120, and that's a good thing because every time now that this Windows Vista machine boots up and it needs an IP address, it's always going to get assigned this same IP address for as long as we have this reservation active. Now, a little bit of warning here. If you've got multiple DHCP servers on your network that could potentially service a client, make sure that you do repeat this reservation on each of those DHCP servers just to ensure that there's no problems with a different server leasing out this address to a different client. Now, our next section down here is Scope Options, and this is where we can configure the things that your DHCP server will provide to your clients when it issues them with an IP address. You see, when a DHCP server issues a client with an IP address, there's still some other things that the client will want to know as well. So by default, over here on the right-hand side, we've got three things that we're also going to pass along when we issue a client with an IP address. So when we give that client an IP address, we're going to tell them also where the router is, or the default gateway. This is the IP address that our client needs to go to when it needs to access a host or a device that's not within its local subnet. So if we were to open up Internet Explorer and we were to go to google.com from a client machine, it'll first go and get the IP address of the Google website. Now, as soon as it realizes that google.com isn't on its own network, it'll need to go to the default gateway to get out onto the internet. So we'll be passing along that information to our client as well, so that way it knows where it needs to go. Alright, we're also going to pass along the IP address of our DNS servers, so our client knows where to go to resolve IP addresses to host names, and we're also going to get our domain name as well. Now this is the default if you chose the exact same settings that I did when you ran through the installation role wizard. But this is by no means a definitive list. You can add in some other options if you like. So if we right click here and choose Configure Options, we're able to add in some other ones. Now in most cases you probably won't muck around with these, but if you're still using Wins in your network, you might want to add that in as well. So let's do that. We'll scroll down. We'll locate number 44, I think, from memory. There it is, number 44. And we'll just need to enter in the name or the IP address of our Win server here. But do take note, we've also got another option here, which is our number 46, which is what allows us to determine the Win's node type. Now if we select that, you can see the type here is OXO. But if we do scroll over to the right here, you'll notice that we do have some other options. Now the first option here is OX1, or a B node, which we'd use for broadcast. This means that your Win's client will only ever broadcast for NetBIOS name resolution, and it won't actually contact the Win server directly. We've got a P node, or peer-to-peer node, and this is where the Win's client will contact the Win server directly, and it won't broadcast anything. We also have the M, or mixed mode, and this is where the Win's client will first broadcast, and then it will contact our Win server if the broadcast didn't resolve the name. And finally, we've got our hybrid mode, and this will first contact the Win server and then broadcast if the Win server can't resolve the name. Now, in most cases with Wins, and I know this isn't a tutorial on Wins, but in most cases you will use this H node, or the hybrid one, and that's what we'll do. I'm going to change this to OX8, and all we need to do then is click OK. Now obviously in my case here I don't really have a need for Win, so I'm going to uncheck these boxes and we'll just go and click OK. Now the thing is, we've just looked at and configured the scope options. Well, obviously it says scope options right there, but underneath we have server options. Now you'll probably note that when you look at these two things are pretty much essentially the same thing. We can set exactly the same options at the server level or the scope level. But settings that we define here in the scope options section, these are going to apply to this scope only and nothing else. So I could have 10 scopes on this server, and rather than configuring all of them separately, we could configure any setting that's going to remain uniform across all these scopes in the server options setting. So on the right here, we can see two things. We've got a DNS server and a domain name. They've already been configured here. Now in the scope, we've got one additional setting, which is our default gateway. Because our default gateway might not be the same. We could have scopes on different subnets, and therefore we'd have a different default gateway. So the moral of the story? Well, any setting that can be reused across all scopes, you should set that here at the server options section. Otherwise, use the scope options section for things that will be unique just to the scope that you're selecting. Now I should also point out that this DHCP console, it also supports RightClick Heaven, which is a disease that affects all Microsoft products, whereby it forces you to right-click on everything just to find all of the available options. So let's begin right-clicking. So if we begin by right-clicking on the very first section at the top, DHCP, we've got two options here. We can add a new DHCP server to this console so that we can manage it from here, and we can manage our authorized server or servers. So to add a new DHCP server to this console, we'd simply choose Add Server and then browse for the server using either Active Directory, or we could just simply select it from the list. Now once you've added the server in and clicked OK, you're going to see that server listed here, available in the left-hand side of the console for you to start managing it. Alright, well let's right-click again. We'll choose the second option to manage our authorized servers. And here you're going to see any servers that are currently authorized. And actually, this is a bit of a crusty interface, this one. I actually don't like it that much. You see, I've got one server here listed, DC01, and that's the server that we're on right now, and it's been authorized in Active Directory, and so it appears here. Now, any unauthorized servers, they will not appear here in this window, so if we click Unauthorized, you can see it makes our server disappear from this window. Now to authorize a server from this window, if we click the Authorize button, we don't get a browse option. We need to know the name of the server. So I'm going to enter in DC01. We'll click OK. Now it's found the server just fine and the correct IP address, so we'll click OK, and it's now reauthorized our server again. Now although this interface does work fine, like I said, I think it's a little crusty. I really would have preferred a list or a browse button there, but hey, it does work. Alright, well let's close this and let's right click on our DHCP server itself, and you can see we've got a few more options to look at. We can add or remove bindings, we've seen that. We can unauthorize our server as well, and we've seen that just before. Now we can also back up and restore the DHCP database. Now before we do that, if we select properties at the bottom here, you'll see the locations of where our database and our backup database paths are. So when we go and right click and choose backup, it's going to take a copy of the DHCP database and it's going to place it right here in the System32 DHCP backup directory. Now this backup will include all of the scope information, registry keys, log files, and DHCP server information, but it doesn't include anything like our DNS dynamic update credentials. Now you can change this path if you like, and in all honesty, I'm a stickler for saving out configuration files and things like that to separate drives, so if you have one, I'd change this to a different drive here. I'd set it to say my D drive or whatever. That way, if the server goes bang, you've got a configuration backup and you can get back up and running real quickly. Now to restore the database, again, we'd right click, we'll choose restore. We'll get our browse for folder window appear, and would simply need to browse to where our backup's located and simply click on OK. Now we will get a message here telling us that our DHCP services must be restarted, so just click yes to begin the restore. Now speaking of starting or restarting our DHCP services, if we right click on our server again and choose all tasks, you'll note here that we're able to stop, start, pause, resume and restart our servers and do just about anything we want to those services from here. Now finally, you'll note we can also delete this server from this console as well. Alright, well let's move on. Let's right click something else. Let's right click our IPv4 settings here. Now in here we've got options firstly to display statistics. Now this is going to give us some information about our DHCP server, such as the number of IP addresses that have been issued to clients. We've got things like our server uptime and the number of DHCP packets that have been traveling back and forth from this server, and even how many IP addresses we have in use. Now the next option we have is a new scope. Now this will simply go through the same wizard we ran when we installed the DHCP role on this server a little earlier in this video. So let's run through it again real quick. So we'll click next, we'll give this scope a name. Now we called the other one New York, so let's call this one LA. I'll leave the description blank for the sake of this lab. We'll click next. Now we'll need to provide an IP address range, so let's go with let's go a different subnet, 64.0.100, and the end will be 10.64.0.200. And now let's click next. In fact, let's change it to 200 again, and we'll click next. Now here we can define any exclusions, so let's set an exclusion of 10.64.0.150 and 10.64.0.160. Let's click add, so we'll exclude those 10 IP addresses there. We'll click next. I'm going to leave the default least duration time here of 8 days. That's fine. We'll click next again. We can also configure the DHCP options, but I'm going to skip this because we've already seen this at both the server level and the scope level for a previous scope. We'll click next and then finish. Alright, well, this time you can see our scope, but it's not activated this time as evidenced by our red downward pointing arrow here. So let's just select our scope and we'll right click on it and then we can choose activate. And that's it. So now what we've got is we've got two scopes that are both ready to dish out IP addresses. And it's just that easy really. You can continue creating scopes for any range of IP addresses that you need to manage. Alright, well let's go back to our IPv4 settings here and right click, and the next option we have here is to create a super scope. Now super scope is basically just a group of scopes. So let's say that these two scopes that we've created, they exist on the same physical network and they're just separated by a switch, but we want to manage them together. Well, we could use a super scope for that. So let's select the option, let's select new super scope, and this will start up another wizard, no surprise there. We'll click next. We'll give this super scope a name. For the sake of the argument, I'll just call this one test. We'll click next. Now here we'll need to choose which scopes we want to add to our list. So we'll select both by holding down the control key and selecting each of them. We'll click next and we're done. We'll click finish. And over here on the left, you'll note we've got a super scope here called test. If we expand that, inside there are both of our scopes. So we can now manage both of them using the single super scope. Now, if we no longer want these scopes to be part of the super scope, then we can remove them. Now, don't delete them though, and don't delete the super scope itself, because doing either of those things is obviously going to delete our scopes. So if you want to keep the scopes, but remove them from the super scope, First thing we'll do is we'll right click on our first scope. We'll select it first, then right click. We'll choose to remove it. Are we sure? Yes, we are. Now we'll go and select our other scope. We'll right click. We'll choose to remove that one. And again, we'll click yes. And note that removing our final scope from the super scope also removed the super scope itself because it was the last scope in the super scope. Now a super scope must have at least one scope in it in order for it to exist. So since we're removing the last scope in the super scope itself is gone. Right, well, let's go and right click on IPv4 again, and the next option here is a new multicast scope. Multicast IP addresses allow multiple clients to receive data that a server sends to a single IP address, which enables point-to-multipoint communication. Now, this type of transmission is often used for streaming media transmission such as video conferencing. Now, with multicast addresses, DHCP clients are not automatically assigned them, they're initiated by the client. So in other words, a client might click on a link, say on an intranet page, and that takes them to some streaming media on one of your servers. Then the client would get a multicast address. So in our wizard, we'll click Next. We'll need to enter in a name for our multicast scope. Let's just call this one Multicast. We'll click Next. Now we'll need to enter in a range of IP addresses for our scope. Now notice that we can't use our regular IP addresses because multicast operations are reserved for the range of Class D addresses. So we'll need to enter in a range that we want to provide multicast for. So how about 224.10.10.10 for argument's sake, and we'll make that through to 224.10.10.50. All right, we'll click Next. Now, like before, we can also add in exclusions to this range. We've seen that again. I'm going to ignore this for now. We'll click Next. We can set a lease duration, which by default for multicast operations is 30 days and not 8, as we've seen for our regular DHCP operations. We'll click Next there. And would we like to activate this right now? We'll say yes, and we're finished. So we'll click Next and then Finish. And here we can see our new multicast scope has been created. All right, well, let's right click again on IPv4, and our next option here is to define user classes. And user classes are useful to categorize, if you like, users or groups of users, and that allows you to handle each group of users' IP addresses needs differently. For example, let's say that you've got a group of mobile users that frequently travel from LA to New York. Now, in this case, we could set a shorter lease duration that only hands out an IP address, say, for 1 day to members of that group. But a desktop user at the same site could have an IP address for much longer. So, by clicking on Define User Classes, this gives us the ability to use one of the existing ones or to add our own. So we could add our own by clicking the Add button and then filling in all of the details. Now, if we go and right-click again and we choose to define vendor classes, this can basically do the same sort of thing, except we would assign vendor classes by the operating system that the person's using. So we could define a different set of DHCP options to a client that's running Windows 98 as opposed to a client that's running Windows 2000 or higher. Now again, we've got some predefined ones, but we can create our own if we like. Now, if we quickly close this and right-click here on our server options and choose to configure options, then over here on the Advanced tab, we can choose our own vendor or user classes from these drop-down boxes here, and then define any options that we want them to have. So, for example, if we were to select the user class of routing and remote access, we could then set our dial-up users to be configured with maybe a different default gateway or a different DNS server. So these options give us a lot of flexibility as to where we want to direct our clients. All right, well, let's cancel this. We'll right-click again on IPv4. The next option here is to reconcile all of our scopes, and this helps us to fix any inconsistencies in the DHCP database. Now, this window's blank as everything obviously is okay right now, but we can click the Verify button, and that'll make sure that everything's well on our DHCP server. Okay, our next option is to set our predefined options, and this allows us to populate fields for our scope and our DHCP server options, or even to create our own options if we like. Okay, well, let's right-click again. And our final option down the bottom here is to look at the properties of the DHCP server itself. Now in our default tab here, the General tab, our first setting is to automatically update server statistics on a specified schedule. Now honestly, I'm not sure what purpose this serves, since the DHCP server statistics, they're manually updated whenever you view them. So automatically updating them to me seems a little redundant, so I wouldn't be turning that on. Now next we can see that DHCP audit logging is enabled, and this will write audit logging information to a file, a log file called DHCP SRV log, followed by whatever the current day is. Now you can turn off logging if you want by unchecking this box, but obviously it's advisable to leave it on because it'll help you troubleshoot problems you might experience later on. Now finally, we can choose to see the boot P table folder by checking this box here as well. Now on our DNS tab, we can configure our DHCP server to talk to our DNS server on the client's behalf. And since this box is checked, that's exactly what will happen. Now dynamic updates for our A and pointer records is also selected, and since both of these first two options are active, what this means is our DHCP server will automatically update the records of any Windows clients from Windows 2000 all the way up to Windows 2008. It's going to update these clients' forward and reverse lookup zones on the DNS server. Now you'll note that discard A and pointer records when lease is deleted is checked by default, and this should probably remain checked as well. What it'll do is it'll contact the DNS server when a client no longer has a certain IP address, and it will let it know that that IP address has changed. Now pointer records are deleted automatically when the lease expires regardless of this setting, so it's kind of irrelevant here anyway. Now finally, the last box here, which is not selected by default, should also be selected if you have older Windows 98, NT and ME clients, because these clients can't automatically update their forward and reverse lookup records with the DNS server. So after receiving an IP address from a DHCP server, the DHCP server will then be able to perform that function for them. Now next we have the Network Access Protection tab. And Network Access Protection is something which we'll be talking about in another video, so we won't cover that here, but just be aware that we are able to enable Network Access Protection settings on all scopes here, or we can disable it from here as well. Again, Network Access Protection is a rather complex subject, and we'll certainly be covering that in other videos. Now, our final tab here is the Advanced tab, and here we can set conflict detection. Now, currently it's set to the default, which is 0. And that means that our DHCP server won't even try to detect conflicts. So to activate this feature, we'd simply need to change this to a value to anything other than 0. Now conflict detection simply makes the DHCP server ping each IP address that it intends to offer to a client, just to make sure that someone else isn't using it. For example, let's say somebody set up their client to use a manual static IP address. Of course, if we enable this and our DHCP server pings the target IP address which it's about to hand out, if that ping fails, that's a possible indication that no one's using that IP address. So the DHCP server can then assign that address to the client. Now obviously that's not a definitive test, because a firewall on, say, a Windows Vista client could simply drop those pings, but it does at least allow our DHCP server a chance to try and ascertain whether that IP address is in use before it goes and hands it out. Now we can also set here the path to our audit logs as well. We could change our server bindings from here as well, and we've seen a couple of other places where we can do that. There's nothing special about this option. Now clicking on the credentials button allows us to select an account that we'd use, which will be responsible for updating the dynamic DNS records on our DNS server. So in here we'd simply enter in a username, a domain and a password, and then click on OK. Alright, now let's go and right click on one of our scopes here. And you'll see we've got some of the same options we had at our server level. We can display the statistics just for this scope only. We can reconcile this scope, or we can deactivate this scope. Well, let's select the bottom option, which is properties, and you'll see many of the same options we looked at with the properties of our server. So we're not going to go through them now. Just remember that these options here are for the scope properties, not the entire server. And as you've probably already witnessed, right at the top here on the General tab, this is where we can change the IP address range of the scope here if you like. So apart from that, everything within our scope is the same as the server. So in this video, we've talked about configuring the Dynamic Host Configuration Protocol, or DHCP role, on a Windows 2008 server. So by the end of this video, you should now know how to install the DHCP server role. You also know how to create single or multiple scopes, how to authorize both a scope and a server so that they're activated on your network. Now you also learn how to add and remove bindings from your network cards so that your DHCP server will be able to use multiple network cards that you choose, as well as how to configure all aspects of your DHCP server, including reservations, exclusions, and a lot more. So we hope you've enjoyed this video and would like to thank you for watching.